Sorry, I thought I was done. There's one more thing I wanted to point out, so this will be a very short video. This is one of the kind of weird exceptions in there. So when you're writing out your KEQ, whenever you have a pure solid or a pure liquid is in your reaction, we assume that that concentration is constant, and so that means that it's not going to change when you get to equilibrium, right? So whenever a pure solid or pure liquid is in reaction, it is not included in KEQ calculation. What does that mean? Here's an example, right? So if we have calcium carbonate produces calcium oxide, which is a solid, plus CO2, which is a gas, right? The KEQ for this equals only the concentration of CO2, right? These two solids, because they're solids, we can't really talk about concentration. And the concentration of a solid isn't really going to change. We're just going to change how much of it we have. And so we don't consider those when we draw KEQ, we write out KEQ. So KEQ in this case would just be the concentration of CO2, which is a thing. Okay. For liquids, this almost always means water, right? So water gets used in a lot of chemical reactions. When you have water in your reaction, we just don't include it in the KEQ expression. So if we do water plus ammonium ion, we get hydronium, H3O plus NH3. Right? So the KEQ in this case, water is a pure liquid, right? And so the KEQ we get in this case is going to be the products, NH3, H3O plus, over the reactants, but we don't include water, so it's just the one reactant, NH4 plus, right? It's assumed that the concentration of water is more or less constant because there's almost always more water around than anything else, and so the small changes in concentration of water that come from it reacting here are not going to really affect the overall equilibrium constant. So we just kind of drop water out and focus on the concentrations that actually change. So this is one thing to just kind of watch out for. If you have water in your reaction, we don't include it in the KEQ expression. If you have solids in your solution or in your reaction, we don't include the solids in there. So this is just one of those kind of like weird, watch out for this thing, because sometimes it'll, when you least expect it, it'll jump out and get you. So don't forget about this. Consider this your warning. There are kind of exceptions to the KEQ rules. All right. I think that's what I wanted to say about KEQ at this point. Thanks.